Inside this ordinary kitchen box, a small vacuum tube converts electricity into high-power radio waves. Those waves are trapped between 6 metal surfaces, reflecting across the cavity at the speed of light before their energy becomes heat in the food. Yet, a person standing only centimeters from the door can watch the process without occupying the same microwave field. The door is only part of the paradox. If electromagnetic energy filled the cavity uniformly, every part of a meal would heat at the same rate. Instead, a plate can contain a boiling region beside a cold one. The turntable is not decorative. It moves the food through an invisible energy map. To understand that map, we must follow the energy from the electrical supply, into the magnetron, through the waveguide, and finally into the material of the food. The exterior contains a metal enclosure and the control panel. Inside are 2 very different systems. The first creates microwave energy. A high-voltage supply energizes the magnetron. A cooling fan removes waste heat. And a hollow metal waveguide carries electromagnetic energy into the cooking cavity. The second system manages the load and safety. The metal cavity, a turntable or field stirrer, the lamp, the door latches, and the interlock switches. The cooking cavity is not merely a thermally insulated box. Its conductive walls reflect the electromagnetic field, keeping energy propagating within the enclosure rather than allowing it to pass outward. The door is part of that electromagnetic boundary. Its perforated metal screen lets visible light pass through, so a person can see the food. But the openings are far smaller than the microwave wavelength, so the screen behaves almost like a continuous conducting surface to the field inside. The magnetron connects to the cavity through the waveguide. It does not blow hot air, and it does not fire electrons into the meal. Electrons remain inside the vacuum tube. What leaves the magnetron is electromagnetic energy coupled into the waveguide and delivered to the cavity. The high-voltage section also explains why the appliance cannot be understood as an ordinary resistive heater. Incoming line power must be converted into the electrical conditions required by the magnetron. Some modern ovens control delivered power differently from traditional transformer-based units, but the functional chain remains the same. The source energizes the magnetron, and the radio frequency path carries its output to the load. The first physical enemy is unevenness. As microwaves reflect between the walls, interacting fields form resonant modes. Electric field amplitude is high at some locations and low at others. Food held in one position may absorb substantial energy at one point, and very little only a short distance away. A turntable therefore carries different parts of the load through several field regions. Some ovens use rotating metal blades in the transmission path to change the field pattern over time, while some designs combine both methods. The second enemy is the cooking load itself. Shape, water content, depth, temperature, and the container all affect how the field is absorbed. Microwaves do not penetrate without limit. Electromagnetic energy decreases as it travels into the food, while heat must continue moving by conduction and convection. The familiar statement that a microwave oven always cooks from the inside out is therefore not a general rule. The final enemy is every possible path by which energy could escape. The cavity requires a large opening for loading food, mechanical clearances that let the door move, and a window for observation. How can engineers provide access to the cavity while retaining the electromagnetic field, even if one door switch fails? The uneven field also explains why cooking instructions often include stirring, turning, standing time, or rearranging the load. These actions do not create more microwave power. They redistribute where energy is deposited and give ordinary heat conduction more time to reduce temperature gradients after the field has stopped. The answer begins inside the magnetron. A heated cathode emits electrons into a vacuum. A radial electric field exists between the cathode and the surrounding anode block. Permanent magnets add an axial magnetic field. With only the electric field, electrons would travel comparatively directly toward the anode. The magnetic field bends those paths. The electrons circulate around the cathode and interact with resonant cavities machined into the anode. Those cavities support electromagnetic oscillation near the designed operating frequency. The oscillating field organizes the electron flow into rotating phase groups. As electrons are slowed by the high-frequency field, part of their energy transfers into electromagnetic oscillation within the cavities. A coupling structure extracts that energy and feeds it into the waveguide. The magnetron is therefore not simply a hot element that emits waves. It is a vacuum oscillator in which electric fields, magnetic fields, resonant cavities, and electron motion operate together. When microwave energy reaches food, the rapidly alternating electric field acts on polar molecules and dissolved ions. Their microscopic motion encounters resistance within the material, converting electromagnetic energy into internal energy. Water is important, but it is not the only contributor to dielectric loss. Composition, temperature, and physical structure all influence the absorption rate. Absorption changes the field that caused it. A large water-rich load draws energy from the cavity differently from a small dry load. Edges, thickness changes, and interfaces between ingredients can concentrate or reduce local heating. This feedback between cavity geometry and the food is why a single time and power setting cannot guarantee the same temperature map for every meal. Door protection uses several layers. The conductive screen blocks the field at the viewing window. The geometry around the door edge and its conductive interfaces restrict leakage around the perimeter. More importantly, United States federal requirements call for independent interlock systems that stop microwave generation when the latch is released or the door is opened. A monitoring function prevents continued operation when the interlock system does not behave correctly. A small mechanical door is therefore treated as part of a high-power radio frequency system. The complete chain can now operate as one system. The user closes the door, and the interlocks confirm an allowed state. The controller energizes the high-voltage system, cooling fan, and turntable mechanism. Electrical energy enters the magnetron. Electrons receive energy from the direct electric field and transfer part of it into high-frequency oscillation in the anode cavities. The waveguide carries that energy into the cooking cavity. Inside the cavity, metal walls reflect the waves and create a complex field pattern. The turntable carries the food through different maxima and minima. Material within the meal absorbs part of the field and converts it into heat. Conduction and convection then reduce temperature differences within the food. Energy not absorbed immediately continues reflecting until it is absorbed by the load, the cavity, or another component. Throughout the process, the door is both an access point and part of the electromagnetic enclosure. Its mesh retains the high-frequency field while passing visible light. The interlock switches do not wait to measure leakage after the door opens. They remove the source by interrupting microwave generation. Safety, therefore, does not depend on a single protective layer. A microwave oven heats food through a tightly controlled conversion chain. The high-voltage supply energizes electron motion in the magnetron. The magnetron creates microwave oscillation. The waveguide couples that energy into the cavity, and the food converts part of the electromagnetic field into heat. The turntable mitigates the uneven field modes, while the metal enclosure, door screen, and interlocks keep energy in the intended region. This familiar box is not merely a fast heater. It is a microwave generator, a resonant cavity, and a layered safety system operating together every time food is reheated.